Here we go. Okay, so we are going to be looking at direct proportion, inverse proportion, and then various other types of proportion. So we already know how to plot something like this, which we talked about last week. So what is always going to be, when I do something direct proportion, there's something that we said was consistent about it. Okay, the gradient is consistent in a linear equation. But if I said, so this is, let's say that is that, and then this is another example of direct proportion. Yeah, what is it?
It always passes through.
Good, it always passes through the center, which means, remember when we talk about y equals mx plus c, right? This is always going to be 0 in direct proportion. So it's always going to go through the origin. So this is really useful for things like converting, miles to kilometers or US dollars to Australian dollars, that type of thing. It's really useful for when 0 is 0, right? But then there are other types of conversions. There are obviously exceptions to that, because if you're converting between Fahrenheit and Celsius, 32 Fahrenheit is 0 Celsius. So sometimes that's a little bit more problematic. But this is called direct proportion. And it's going to look like y equals kx, where k is just any number, okay? We can also have indirect proportion, or inverse, sorry. So inverse proportion is where you have, well, actually, I'm going to make it k. You have a number and x is at the bottom of a fraction. So we're saying that x is inversely proportionate to y. All right. And you get completely different things with that. We're not going to graph anything that looks like this, but we are going to do conversions by just using information. So let me save that and let's do an example of those things. All right. Let's say y is proportional. Actually, I should write it better, shouldn't I? Y is directly proportional to x if y is 12 when x is 3. Oh, I should not put a question mark there yet. What is y when x equals 5? So what I'm going to do is I'm going to set this up as an equation. So direct proportion is y equals k times x. We watching? Okay, so this is our formula for direct proportion. I know that when y is 12, x is 3. Right? So now I can find k. So what's k? Good. K is obviously 4. So then I'm being asked, what is y? So that means the equation is this, correct? So now what is y when x is 3? 5, sorry. Why did I say 3? So that means y is 20 when x is 5. Make sense? Yeah.
Why couldn't it be 3x plus something?
So if it's direct proportion, there is no, or the y-intercept is always 0. Okay? So yeah, you were out of the room when we just reminded ourselves of that bit. So there is no plus c. The plus c is always plus 0, so you can just use this formula. The same thing is going to be true if we do this for inverse proportions. And then we can do all sorts of things other than that, but let's just do that first. Okay. So y is inversely, why can't I spell that? Inversely, that's not how you spell that. I can't write and speak at the same time. That's not right either. I don't care. Whatever. I had it right the first time, didn't I? Inversely proportionate. I cannot speak and write at the same time. To x. When x is, what am I going to do? Oh, that's not what I meant. Okay, let's say that I give you something like this. So I said y is inversely proportionate to x. So y is going to equal k over x, right? Inversely proportionate. So all I'm going to do is shove the information I have into this and find k. So y equals k over 8. So what is k? 24, right? So I bring this across and say 3 times 8 is k. So then k is 24. Now, this time I gave you x instead of y. Last time I gave you y. Oh, actually, I don't think I did. Yeah, I gave you x. Oh, okay, whatever. All right, so what is y? We know that k is 24, and I've just told you that x is 4. So what's y? Said 8. Boo. Okay, so y is going to be 6. So again, this equation would be y equals k is 24 over x. That's the general equation of this. Does it make sense?
Yeah.
So we're just plugging in the information. We find k, then we find the next set of information. Now let's look at something that's kind of weird. And this really requires you to be able to interpret the words. If I say y is inversely proportional to x squared, what is x when, oh, hang on, I need more information than that. When y is 2, x is let's say 5. What is x when y is 6? Okay, so let's try and write this out. So I've now given you something that we haven't seen before. I want you to take a second and try and picture what the equation I'm giving you is. Don't yell it out. I want everyone to have a chance to turn this top sentence into an equation in your mind. Y is inversely proportional to x squared. All right, y is inversely proportional to x squared. Okay, so it should look like this. Now I need to find k. That's always my first job. Boys, stop talking. So I'm going to put in these two numbers to find k. So that means 2 equals k over 5 squared. So then 2 times 25 is k. So k is? Obviously, it's 50. So now I need to do the other part. When y is 6, so I've got 6 equals 50 over x. What do I do? Good. Okay, I did not write square, did I? Okay, so what should I do? Sorry? Okay, I'm going to do it 2 steps at a time, but that is what I would do. I'm going to bring across the x as a multiplication. Remember, always move the bottom of your bracket first. Then I'm going to bring over my 6 as a division. Then what do I have to do to this? Square root it, right? Now, is this going to be a nice answer? No, it's going to be a horrendous decimal, but that's okay. We're allowed to have that. What is it? All right, so you're allowed, shh, guys, you're allowed to have decimals sometimes. You might need to do a bit of rounding. Most of the time, they're going to give you nice whole number answers, but not always. If you get a decimal, it doesn't necessarily mean you're wrong. The important part is making sure you understand this sentence. Let's do one more. Y is proportional to the square root of X. I want you to take a second and try and picture this. Try and turn this into an equation. Y is proportional. I should have said directly proportional. Y is directly proportional to the square root of X. Have a think about what that would look like as an equation.
Square root of X. I think I know.
Good.
I'm just giving it a one.
Try and picture it. So if we said this is what direct proportion looks like, Y is directly proportional to the square root of X. That's what it should have looked like. Have I given you any information to do anything more with this? No, absolutely not. So in this case, you would just